Hello, my dear champions. Welcome to the class. Today, I'm going to discuss one very important concept from the chapter differentiation, that is second order derivative. Second order derivative. It comes for 5 marks. This comes for 5 marks. 1 second. 5 marks in your second PUC board, a guaranteed question. Okay, and it also is very useful in your KCET as well. You'll have one question on the KCET. Okay, so of course one question in the KSAT, one question of 5 marker in your boards, and one question of 1 marker in your KSAT. So I'm going to discuss this concept as well as I'll take some problems on it and solve with all of you. Okay, so in this session we'll learn this concept, we'll revise this concept very well so that we'll not make any mistake in our any of the exams, whether it is midterm, whether it is preparatory, boards or KSAT. Let's start. Let us start. So how do we what is the understanding of this chapter? So first thing first, have a look. 1 second. Yes. Okay. So first thing first, if you have a function given in the explicit form as y equal to fx, even if you have given in the form of implicit way or parametric form, so this kind of question is applicable to even the implicit functions, okay, or it can be also be applicable to parametric functions. I have discussed those as well to all of you. Please go and check it out. Okay, so implicit function or parametric function or clear explicit function, there can be different variety of questions in which the function is given to you, and then they can ask you to find the second order derivative, or they can ask you to prove a given equation of second order derivative. Means they'll give you a equation of derivative and they'll ask you to prove that using a given function of various forms, explicit function, implicit function or parametric function. Okay, we'll discuss all those in the class itself, in the session itself today. So what we do, we simply start with doing the or taking the first derivative. Whatever function is given, whatever form is given, for that form we'll do the first derivative, means find the dy by dx. If it is given directly y equal to fx, we'll find that. Given in the form of equation, we'll find that. And then once you have this notation as f dash of x or dy by dx, okay, simply called as rate of change of y with x, then what you do, you differentiate the derivative number 1. This is obtained as, please check here, this is obtained as d square y upon dx square. This is the notation for second derivative, and this is obtained by differentiating the first derivative with the same variable x. Derivative of y is with x is dy by dx. Differentiate the same, differentiate the first derivative with the same variable x, you get the second order derivative. So there is notations. Either you write this form, you write f double dash of x, you write y2 y double dash d2y, same thing. Okay, what is the meaning of it? So if I take example where y equal to fx or s represents a displacement function, this is a displacement function, then the second derivative is nothing but acceleration, because first derivative will be what? Velocity, right? And second derivative will be what? Acceleration. Okay, so second derivative of displacement will be acceleration. This is the one physical meaning or example of second derivative in science. Okay, let us move on. So how to find second derivative? Very simple. Differentiate the y with x to get dy by dx. Next is differentiating this again with the same variable x. You cannot change the variable. Same variable x, you can get what? D square y upon dx square, right? So what happens, sir, if we are having a question of parametric form, then we'll find dy by dx also in the form of parameter, right? We cannot change the variable. If I'm looking to find d square y upon dx square, which is second derivative, I have to always keep this same, x and x. First derivative in the variable x, second derivative also in the variable x only. Next, simplify the result and substitute the value in a specific point as it is asked. So whether it is asked in the equation format or it is asked you to find the value, whatever it is given to you, you're going to utilize the two conditions you obtained in first and second derivative in the question application. Clear? This is how you find and solve the questions on it. Okay, some of the important derivatives, okay, that we have: the polynomial function, xn is n minus 1, sin x is going to be cos is minus sin, tan is secant square, log is 1 by x, e power x is x, A power x is A power x ln A, and UV rule, product rule, this is the chain rule. And the chain rule. Makes sense? I hope this is clear. Let's look at some questions now. So we have quickly recalled the concept part, not much is there, but let's look at question application as well. So in the 5 marker category of board questions, there is a proof based question that comes. Let's look at this. The first one I've taken on the parametric form itself. If x is given as a cos t plus t sin t, and y is again a times of sin t minus t cos t, this is the parametric form. We need to find the value of second derivative, basically prove it. This is the condition. Let's do it. How do you find it? So let's start from finding. To find this, we have to find what value? Dy by dx. How to find that? Dy by dt upon dx by dt. To find the first derivative, we have to use the parametric form. Then we have to, then only after finding this value, we have to find the derivative of this part, right? So let's find this first. Okay. So let's start with dy by dt. Y is over here. A is a constant. We'll keep A outside. Sign becomes what? Cos t. There's a minus sign. Put a minus sign. Okay. T will be 1. So we'll write here 1 times of cos t. Next will be what? T as it is, cos becomes minus sign. T as it is, cos becomes minus sign. Excuse me. 1 second. Let me erase this. Yes. 1 second. Okay. So we'll write here minus sin t. Cross check now. So you'll have over here this cos and this cos is cancelled. Plus and minus is cancelled. And we'll have over here minus and minus becomes plus. So you'll have a t sin t. What is this? Check here. This is minus sign, right? Over here minus sign, it becomes plus a t sin t. Okay. Did I miss something? No, right? No. This is dy by dt. Let's go and find dx by dt now. Let's find dx by dt now. Okay. Oh, sorry. So x is over here. Differentiate that. Differentiate this part. You'll end up with again a as it is. Cos derivative will be minus sign. Minus sin t. Plus, there is a plus sign over here. Differentiate this t. You'll have 1 sin t as it is. Plus t will be as it is. Sin will be cos t. Right? Product rule. Have a look. Minus sign plus sign is cancelled, and you have a t cos t. You have a t cos t. This is my dx by dt. This is my dx by dt. Have a look. So dy by dx now is coming as dy by dt upon dx by dt. The numerator becomes what? Check. At sin t by at cos t. At cancels. We have simply tan t. This is the value for what? Dy by dx. Now this is in the parameter t again. I told you to find second derivative, we have to do in the same variable, which is x in this case. We'll continue like this. D square y upon dx square. We have to differentiate this. So tan t becomes what? Secant square t. Is it sufficient? You have to apply the chain rule, because you have to differentiate t with x now. So dt by dx. Dt by dx. We have dx by dt. Can you check? We have dx by dt. So from here we can find what? Dt by dx, and that will come as 1 upon at cos t. Reciprocal we can find. Okay. Put the value over here. Secant square t 1 upon at cos t goes up, becomes what? Cos will become sec again. Sec cube t upon at. Upon at. This is the value for second derivative. Let's just cross check this part. Check. Sec cube t upon at. We have to prove that only. So this is the question that carries 5 marks in your boards. Parametric form application also alongside with second order derivative. Okay, this is clear, right? Yes. Let's practice one more question. Here we have sine of sin x. We need to prove this condition. So the first question that we solved right now was on the basis of simply, you solved it and you get the result directly. You solve for first derivative, second derivative, you got the result. But this one is where you have to find the value of second derivative and first derivative and utilize in the equation to prove LHS equals to RHS. So both kind of questions can come in the 5 markers. Starting with derivative number 1. Try. dy by dx will be what? First sine. So you're going to have cos of sin x. This is going to be what? Chain rule, right? Sine will be differentiated over here, it will become cos of sin x. But if you differentiate sin x also inside, which is there, you're going to have, we have the answer as cos of sin x into cos x. Clear? This first derivative. All right, sir. Great. Let's start now again with second derivative. So you have to apply product rule as well as chain rule together. Let's try. So dy by dx we're going to find d square y upon dx square. Let's differentiate cos sin x, will have minus sine of sin x. I'm differentiating this part. Minus sine of sin x. Now differentiation of sin x will be what? Again cos x. This is just one part. And that cos x is as it is. That cos x over here, excuse me, that cos x is as it is. This cos x over here, no, I've kept as it is. Differentiating the first part, right? Cos becomes minus sine, the sine becomes cos. Then comes a plus sign. We'll keep this as it is, cos of sin x. Differentiation of that cos becomes again minus sin x. Minus sin x. Take minus sign common, you have sine of sin x into cos. We have cos square x, and over here plus cos of sin x into sin. This is different, okay? They are two different terms. That's the result. Second derivative. So basically in the question that we have, the equation that we have to put this value. Check. We are having in the, we just take the LHS part. We have d square y dx square plus tan x dy by dx, tan x dy by dx plus y cos square of x plus y cos square of x. We're going to start substituting the values. This was there, minus sine of sin x into cos square x plus, correct, cos of sin x into sin x. Okay, so cos of sin x into sin x. This is the value for second derivative. Please check. Sin of sin x, cos square x, cos of sin x into sin x. First part. Now next is what? Tan x. Tan x becomes what? Sin x by cos x. dy by dx value is what? That is cos of sin x into cos x. Right here. Cos of sin x into cos x. This is the value for dy by dx. And plus y. What is the value of y? Sin of sin x. So we'll write this. One second. Y will be sine of sin x into cos square x. Am I right? Y sine of sin x into cos square x. So this value is for dy by dx, by the way. Not cross check. Just cross check. This cos x and this cos x cancels. Right? And do the expansion now. So you'll have over here minus sine of sin x into cos square x. Over here what do we have? Plus, so this will also be minus, right? This will also be minus only. Because you are doing expansion right over here. This minus will also act on this minus, so it will become minus cos of sin x into sin x. Over here, what do we have? Sine multiplied with this thing, so sine of cos, sin x into cos of sin x, right? That's the term. And the last one is plus sine of x into cos square x. Cross check. Sine of x into cos square x negative. Sine of x into cos square x positive, cancel. Minus cos of sin x into sin x plus cos of sin x into sin x, cancel. So why this whole thing is coming equal to 0, which is nothing but RHS. Check here. What we are getting? LHS equals to RHS. What we are getting? We have to prove this. We have to prove this condition. These are the two 5-marker questions. Two very different type of questions, and very useful for the second order derivative of second PUC type problems. Have a look one more time. Download this PDF. Okay. Take a screenshot if you want to right now and start using it right away. Okay. We have given you all our AIO platform, a next gen learning platform. You find everything over there, notes, you find lectures, doubt solving. Just click on the link given in the video description. Just go and check on the description side. ACE Creative free ACE KCET test series. I'll give you the link also. Just 1 second. Okay. Yes. So it goes like this. Free ACE KCET 2027 course. Click on this link. Okay. You'll find the link over here. Click on the link and get our AIO platform access, all-in-one platform access. Create login, start using it over there as well. This is clear, the questions are clear. Okay, moving on. Let's solve some questions of KCET style as well. Okay, like 1 marker, single MCQ. So first, there total I've taken 3 questions. You have to give me the answer for the last one from your own side. Y equal to e power ax is there. I want to find out second derivative. How do you find out, sir? So if I find dy by dx, I'll have the answer as exponential function is there. It'll remain as it is. E power ax remains e power ax only. But ax, if you apply the chain rule, will be into a second derivative. Again, e power ax remains e power ax only. Already we have a. Differentiate this also, you're going to get another a. What is the answer? A square e power ax. Option A. Option A. This kind of question can be asked in your, MCQs of boards, right? Okay. Now this one. X is cos t given, y is sin square t. A very good question. What is the answer for this problem? How do you find it? Can you see there's a relation between these two formulas? There is, right? If I have y equals to sin square of t, doesn't it mean y equals to 1 minus cos 2t by 2? Formula is there. Sin square t is 1 minus cos 2t by 2. Cos 2t is x. So y equal to 1 minus x by 2. Differentiate. Dy by dx becomes equals to, for 1 will be 0, for x will be minus 1, and we have 2 over here. For x will be minus 1 and we have 2 over there. So my value of derivative is coming as minus 1 by 2. Differentiate again. Second derivative. Means I have to differentiate the constant also. I have to differentiate the constant also. That is how much? 0. So my answer is option A. By looking at the question, we start thinking of parametric form, right? Differentiate this sir with t, this with t sir, then take the ratio, then differentiate again. But look closely, you will find a formula being built over here. And because of that, these questions can be solved faster. Tell me, how was this? Okay, so this was the understanding of second order derivative with the help of parametric form, but use the formulas also in the trigonometric functions that is available. Option A is the right answer. This one I want all of you to solve. This is the homework. I want basically from all of you in the comment section, what is the answer for this question? And this is the PYQ, by the way, of CET. This is the KCET PYQ. and also PYQ of boards. Also PYQ of boards. I want answers from all of you for question number 5. Option you can see y is given as a sin x b cos x. Option is y minus y 0 and 2y a b c d. You have to let me know question number 5. Answer is this, sir. So that was it in this class today, where I talked about second order derivative and its application in second PUC your boards, where it comes for 5 marks, and also in your KCET, where it comes for 1 marks. Okay, let me know how was the session and what else topic you want me to cover up in this series, where I'm discussing one concept at a time and solving questions of that particular concept to boost your confidence in, okay, to boost your preparation with confidence, right? And of course, I'm here to help you, assist you in that. So whatever request you want to make, let me know in the comment section. I'll help you with that. I'll help you prepare in the best way for that. Okay, let's take one step at a time and we'll be good, we'll be prepared in the best way. That's all in this class. I'll see you all in the next one. Till then, take care. Bye-bye. All the best.